Dear students, how are you all? Hope you all are fit and fine. We know that due to Corona, we all are inside the home. You all are enjoying, isn't it? From today onwards, we are going to concentrate in our studies. As we all know that beginning of something new is always amazing. I'm talking about the new academic session. Come on, let's go into the class. I'm going to teach you physics. Now, I'm going to start the new chapter, Unit 1 Nature of Physical World and Measurement. From the topic itself, you may know that physics talks about the nature by using the measurement. Now, what is science? You all have studied from your early classes itself, isn't it? Okay. The science is the systematic study to determine the wonder of the natural world through observation, experimentation, and logical reasoning. Science is full of wonders about the nature. Our human mind is very curious to know and understand different phenomena like why the sun is shining very brightly in the morning, why there is rainbow after rain, why volcanic eruptions occur, why tsunami happens, how the motions of planets are occurring, how lunar and solar eclipse occurs, why there is seasonal changes, climatic changes. Isn't it? You're having the doubt now? Yeah. The answers for these questions by applying the laws of nature and laws of concepts is called science. Okay? Now you're understanding, I think so. Okay, in your mind, you fix there is an apple tree. In the apple tree, you classify it into three parts: fruits, branches, and root. Root, branches, and fruits. Okay, now the root is science. The root is science, and the branches are engineering, and the fruits are technology. Nowadays, without technology, we are nothing. In each and every home, everyone are using technology like television, mobile phones, laptops. Nowadays it's very important one. So the technology came from engineering. Engineering came from science. Yeah. And that science that in the root we tell in Tamil that aniver like that. So in that aniver is physics. So physics is a most important science. Okay. In previous days, oral communication was the mode of conveying the knowledge when writing systems was not yet developed. So the word science has its Latin from scientia. The Latin word scientia is converted as science, which means to know the truth, arivial, to know the truth. So our mind is very curious to know the truth about the nature, about the wonders of the world, why it is occurring, why it happens, like that. So lot of questions in our mind. So by applying laws, by applying some physical methods, by applying observations, experimentation, we get answer for the nature's changes. So this is about physics and science. Name physics came from physis. It's a Greek word. The physics name given by Aristotle in 350 BC. Okay? Okay. Systematic method is a step by step approach, okay, in studying the natural phenomena and establishing the laws. It is a step by step approach to get the answer. Okay, first, systematic observation. What happens if we do this? What happens? We'll get answer like that. And doing controlled experimentation, doing very carefully for many days to get the answers. Qualitative, quantitative reasoning like that. Qualitative means very quality, and quantitative means in numbers. Reasoning means very thinking, prediction like that. Mathematical modeling also, by applying the formulas we are getting answer. So scientific method is a step by step process to get the answer. There are very many methods to get the answer for the nature's changes. Okay, for example, you see in the picture there is a metallic rod. Okay, yeah, man is having a metallic rod in his hand and it is heated by a candle. Okay, okay, consider a metallic rod. It's being heated. When one end of the rod is heated, what happens? What happens within the rod when it is heated? The man will feel heat in his hand or not? Yeah, you're right. His hand will be heated. So, how it changes? The heat transfers from hotter area to the colder area. So, this process is known as conduction. This process is known as conduction. How they name it as conduction? By doing the systematic observations, by doing controlled experimentation. So, finding the answers for nature by applying the scientific laws is the science. How the heat react each other in by the process of conduction. Does it affect every material? It is a metallic rod. Does it affect other materials? Of course, like copper, aluminium, gold, silver. Like these materials also, if it is heated at one end, it reflects at the other end. If we heat the in many factories like that, we will see now the iron rod or metallic rod is heated red hot, fully red hot. Okay, heated, and we will see the sparkles coming out. It becomes very red hot, and other side they will handle with some machines or some cloths like that. In that process, the heat energy, the giving heat is converted into light. We are seeing the red color light like that, sparkles also. So heat energy is converted to light energy. This is the process of finding the answers to the queries by scientific investigation. Okay, I have given an example for you to understand it. How we get answers for our doubts. Like that, why the sun shines bright? Why the rainbow came after rain? So lot and lot of questions in nature. So finding the answers for that questions is called science. Okay, have you understood, children? Okay. What is physics? We already studied, isn't it? Physics came from the Greek word physis, which means nature. Study of nature by applying the laws of nature is called physics. Okay, physics is the most basic of every sciences. It is the fundamental base for engineering. The two most important approaches in physics is unification and reductionism. Unification and reductionism. What is unification? Attempting to explain diverse physical phenomena with a few concepts is called unification. For example, Newton's universal law of gravitation, which explains the motion of freely falling bodies towards the earth. Already you have studied, isn't it? Or we will study in further in the unit 6 itself. Newton's law of gravitation, which explains the motion of free falling bodies towards the earth, motion of planets around the sun, motion of moon around the earth, thus unifying the fundamental forces of nature. So, there are many things in the universe, isn't it? Many concepts into a simple concept. This is known as unification. What is reductionism? It is an attempt to explain macroscopic systems, very large systems, in terms of microscopic systems. Very large systems such as macroscopic properties means entropy, temperature. These are macroscopic properties. For explaining the macroscopic properties, we are using microscopic properties. So for describing macroscopic properties, we are using microscopic. For describing very big one by small one, this is known as reductionism. Unification means a large heavenly bodies, large motion of bodies in the universe into a single law. Many wonders of the world by a single law. There are many laws: Newton's first law, second law, third law. So in Newton's first law itself, there are many wonders. To each and every action there is an each opposite reaction. In Newton's third law, we know now. So for that only we are having lot and lot of examples. That is unification. Many things a single concept. Many things a single concept is unification. A large macro property, a large thing defined by a small thing is known as reductionism. Have you understood, children? These are the two approaches in physics. Now, branches of physics. Physics has many branches: nuclear physics, quantum physics, atomic physics, molecular physics. Chemistry is also a branch of physics, optical physics, spectroscopy. So, many branches of physics are there. Physics is a fundamental science which helps to uncover the laws of nature. What is the language of physics? In which language physics is described? Yes, you are right. Mathematics. Physics is described in mathematics. In ancient times, in the old ages, humans lived with nature. Their lifestyles were integrated with nature. They could understand the signals from the movement of stars and other celestial bodies. They could determine the time to sow and reap by watching the sky. You also hear that வானத்தை பார்த்துட்டு விவசாயிகள் காத்துட்டு இருப்பாங்க எப்போ மழை வரும் வானத்தை பார்த்துட்டு வயல் நடுவாங்க like that. So in olden ages, the people understand the signals from the nature itself. Thus, astronomy and mathematics were the first disciplines to be developed. So, astronomy means prediction of the future. Mathematics is a language of physics. So, these both combine together to form the physics. There are lot and lots of branches: quantum mechanics, nuclear physics, combination of two. Physics combines with chemistry also and physics also. So, this combination becomes the branches of physics. Physics is classified into two main groups: classical physics and modern physics. What is classical physics? Classical means traditional. Traditional means in old ages, before the beginning of 20th century. In old ages, before the beginning of 20th century, classical physics is followed because there were not any laws or concept, not any written laws like that. So only oral communication was in the last past years. So before the beginning of 20th century, we call the physics as classical physics. Nowadays, after the beginning of 20th century, after 20th century, the concept has came, and it has a written statement, and the laws concept, everything is given. So it is known as modern physics. Now we are living in the world of modern physics. In the classical physics also, there are many classification. Come, let's see. In classical physics, it is classified into mechanics, thermodynamics, optics, electricity and magnetism, acoustics, astrophysics, relativity. Mechanics is further classified into statics, dynamics, and dynamics is further classified into kinematics, kinetics. This is classical physics. Okay. Then what is mechanics? What is mechanics? The study of forces, okay, acting on a body, whether at a rest or in motion. A body is rest. If we give a force, the body will move. A body is rest. If we give a force, it will move. So the study of it is mechanics. Study of it is mechanics. Study of a body at rest or in motion by applying the forces is known as mechanics. Then what is thermodynamics? Thermo means heat. Thermo means heat. The study of relationship between heat and other forms of energy. Heat and other forms of energy பத்தி படிக்கிறது thermodynamics. And what is optics? The study of light. Optics. Optics means light. So study of light is optics. And then electricity and magnetism. The study of electricity and study of magnetism, their mutual relationship between electricity and magnetism. This is known as electricity and magnetism. What is acoustics? Acoustics means it is a sound. Also, the study of production and propagation of sound waves, how the sound is produced, how it travels, like that. The study of sounds is known as acoustics. Then astrophysics. What is astrophysics? The study of physics of astronomical bodies, heavenly bodies. Okay, so study of that astronomical bodies like skies, moon, stars, celestial bodies. Okay, study of that astronomical bodies deals with astrophysics. Then relativity means what? It is a connection. Relative means சொந்தக்காரங்க, நெருங்கின உறவு, like that. So relativity means the combination of two or more bodies, the relationship between space, time and energy. So space, time and energy. So combination of three or combination of two. So the relationship between both of them, okay, both of them, space and time or space and energy, okay, by launching the rockets. So space is also there, time is also there, energy is also there. So like that, the relationship between of space, time and energy is known as relativity. So these are classical physics. Have you understood, children? Okay. Now, modern physics. What is modern physics? I already told that it refers to the concepts that have surfaced since the beginning of 20th century. After 20th century, the concept in physics is known as modern physics. That is classified into quantum physics, atomic physics, nuclear physics, molecular physics, high energy physics, condensed matter physics. Okay, right. Quantum mechanics, the study of discrete nature of phenomena on atomic and subatomic levels. Quantum means it is a chemistry word, isn't it? Quantum means atom, atomic particles, protons, neutrons, subatomic particles, very, very minute particles. So, study of that atomic or subatomic levels, very minute. In physics, we can also study about very large astronomical particles like that sky, stars, moons. The distance is very large, and also very minute particles like electrons, protons, the atoms. So physics deals with both of them. This is the wonder. So physics is very interesting subject. It deals with the nature and it deals with each and everything which we are seeing, which we are experiencing, which we are meeting, it happens accidentally. So these about full and full of nature is physics. So quantum physics deals with atomic and subatomic particles. Have you understood? Next, atomic physics. What is atomic physics? That atomic physics deals with the structures and properties of atoms, how the atoms are moving, how the atoms are forming, like that. So, structure and properties of atoms determines atomic physics. What is nuclear physics? It deals with the structure, properties, and reaction of nuclei of the atom. In atom, we know that nucleus, electrons, protons, and neutrons are there. So nuclei present in the center of the atom. So studying the reaction, studying the structure and properties of the nuclei is known as nuclear physics. Okay. Next, high energy physics, the study of nature of the particles, very minute particles in the nature. So study of that particles is known as high energy physics. Condensed matter, what is condensed material? Solids, liquids, gases. Solids, liquids, gases. So study about their properties and intermediate between them, okay, and their subdivisions such as nanoscience, how the car works, petrol, diesel, gases. So study about that condensed matter of physics, that is known as condensed matter physics. Okay, have you understood, children? Okay. Scope and excitement of physics. Physics is used in many places. It has a great scope. The discoveries in physics are of two types: accidental discoveries and well analyzed discoveries. Accidental discoveries means it happens very accidentally, எதிர்பாராத விதமாக. So accidentally it happens. Well analyzed discoveries means it needs more time by doing observations, experimentations for more days, and finally they will get the result. So accidental discoveries, like for example, a person was walking in a street. He observed magnetism accidentally as he's having iron in his hand. Further, his iron is attracted by a magnet. Hence, he realized there is a magnetism. Hence, after he realized the strange behavior of magnets theoretically and revealed the phenomenon of magnetism. With this knowledge, artificial magnets were also prepared in laboratories. So, accidental discoveries may further converted to well analyzed discoveries also. Theoretical predictions are the most important contributions of physics. They predict it may happen or it may not happen. Lot of confusions finally give the answer for that predictions. For example, the famous equations, Albert Einstein's equation. Do you know? Yeah, you are right. E is equal to mc square. That E is equal to mc square was a theoretical prediction in 1905. In 1905 itself, Albert Einstein theoretically proved that E is equal to mc square, but it is experimentally proved in 1932. See how many years gap? 1905, 1932. So experimentally, it has taken lot and lot of times to prove. So it is proved by Cockcroft and Walton after. So theoretical prediction done by Albert Einstein, experimental prediction done by others. So this physics is very interesting subject which deals with nature. It also used in pharmaceutical industries in preparing the medicines, drugs. So in medical field also physics is surviving. Biocompatible materials for organ replacement. You may also hear that lot and lot of organ replacement are happening nowadays. So many people got accidents or some problems in heart, brain like that. So for changing that organs, we are fixing biocompatible materials by fabrication. In that concept also, quantum physics is taken place. Physics has a huge scope as it covers a tremendous range of magnitude of various physical quantities: length, mass, time, energy. These are physical quantities. It deals with length, mass, time. It deals with very large magnitude in astronomical phenomena. In astronomical, that large bodies, okay? It also deals with the large bodies, and also it deals with very small magnitude electrons and protons. So physics is in everything. Where minute also physics, in large bodies also physics. In range of time scales like astronomical scales are very large, and up to microscopic scales. Microscopical scales are very small. 10 power 18 yes to 10 power minus 22 range also the time scales of physics ranges. Next, range of masses from large heavenly bodies to electron. Large heavenly bodies to electron, 10 power 55 kg to 10 power minus 31 kg. So, the study of physics is not only educative, it is very exciting. You are all excited, no, to study physics? Are you interested to study physics? Yeah, very good. You are very interested. Yeah. So, study of physics is not only educative, it's very exciting. A small number of basic concepts and laws can explain a diverse physical phenomena. Very small basic concept and very easy laws only that describes a very diverse physical phenomena means that describe the world. A simple law describes the whole concept, whole wonders of the world. The most interesting part is the designing of useful devices on the base of physical laws. For example, use of robotics. In robotics also, physics is used. Journey to moon and by nearby planets, in rockets you are going. So technological advances in health sciences also. So physics in each and everything there is physics. It carries out the unfold secrets of the nature. In nature there are many secrets. Some secrets still now we don't know. So when we are breaking the secrets, we will get the answers. So the nature's secrets are revealed by physics. Natureoட secrets physics ஆல உடைக்கப்படுது. So probing and understanding the science behind natural phenomena like eclipse. Okay, why one feels the heat when it is fire? Why it is heating? What causes the wind? Why the wind is coming? Why there is lunar eclipse? Why there is solar eclipse, like that? So for understanding and determining the answers for these type of questions, physics is used. In today's world of technological advancement, the building block of all engineering and technical education is physics. Physics plays a vital role in engineering field. So the language of physics is what? Mathematics. So it is explained, it is written form in mathematics. So hence these are the scope and excitement of physics. Do you understand, children? Okay. Physics in relation to technology and society. How physics is related to technology and how is related to society? Come, let's see. Technology is the application of principles of physics. Technology means, okay, for example, you are having a cell phone. That cell phone is the application of principles of physics. It is used for practical purposes. So we are using our cell phone for our practical purposes, and the applications and principles are involved inside the technology. So this is technology. The application of knowledge for practical purposes in various fields to invert and produce useful products to solve many various problems, technology is used. So that technology is used for society as directly or indirectly. Okay, for example, if you are very expert in wireless communication, okay, if you are expert in wireless communication, how you become expert? You may know the laws of electricity and magnetism. If you experience the laws of electricity and magnetism, then only you can discover the wireless communication technology. So, after the discovery of wireless communication, the world has shrunk, which effective communication over the large distances. From here to America, we can call it a second. So, this is wireless communication, it the basics of electricity and magnetism. The launching of satellite into space, okay, the launching of satellite into space, which has created a revolution in the field of communication. So these are very great wonders. So this basic is physics. And further, microelectronics, lasers, computers, superconductivity, nuclear energy have comprehensively changed the thinking and living style of human beings. Now our lifestyle is totally changed. So you think 20 years back, what happened, how our grandparents lived, and now how we are living. So you think, and just the change is done by physics. The change happens by technology, and technology came from physics. So, physics being a fundamental science, it has played a vital role in the development of other sciences. Each and every places there is physics. Let's see how physics is related with each and every sciences. First, physics in relation to chemistry. How physics is related to chemistry? In physics, we study the structure of atom. Chemistry abdinale atom. So, in chemistry, we study the structure of atom, radioactivity, X-ray diffraction, etc. So, by studying the structure of atom in physics, we can arrange the elements in periodic table in chemistry by the atomic numbers. So, physics or in the structure of atom in physics determine the periodic table on the basis of atomic numbers. It also helps us interdisciplinary branches. Physics and chemistry are interdisciplinary branches. Physical chemistry, quantum chemistry, like that. So it is an interdisciplinary. Physics mingles with each and every science. So it mingles with chemistry in a better way, like a brother and sister, like that. Physics and chemistry are very mingled. Next, physics in relation to biology. So how in biology physics is used? For as a electron microscope, for example, as electron microscope, it has made possible to see even very small structure, very minute structure like cell, virus, etc. So X-ray, neutron diffraction techniques has helped us to understand the structure of nucleic acids. X-rays are used to diagnostic purposes, for seeing is there any stone or any baby formations. So X-rays are used. Radioisotopes are used in radiotherapy for cancer treatments. In recent years, biological processes are being studied from physics point of view. Then physics in relation to mathematics. We all know that mathematics is the language of physics. So they are very, very closely related. Physics is a quantitative science, full and full of numbers. Physics is determined and written in numbers. So it is most closely related to mathematics. It is a tool for its development. Mathematics is the tool for the development of physics. So, physics in relation to astronomy. How physics is related to astronomy? In astronomical telescopes are used to study the motion of planets, how the planets are moving, how the movement of moon, sun, stars, earth, like that. So, heavenly bodies ஓட மூமெண்ட்டை பார்க்கறதுக்கு astronomical telescopes are used. Radio telescopes has enabled the astronomers to observe distant points of universe. Studies of the universe are doing by physical principles. Okay, physics in relation to geology. How it is used? To study the crystal structure of various rocks, mountains. Okay, so study the crystal structure. They are applying diffraction techniques to study the crystal structure of various rocks. Next, radioactivity is used to estimate the age of rocks, fossils, and the age of earth. Age of the rock. We can also determine the age of rocks, age of the earth by radioactivity. So, physics is related in geology also. Then, physics in relation to oceanography. Oceanographers, study of oceans and that related things. Oceanographers seeks to understand the physical and chemical process of oceans. They measure the temperature of the waves, sea, salinity, the current, speed, glass fluxes, chemical components like that. Physics in relation to psychology. All psychological interactions can be derived from a physical process. The neurotransmitter is or a liquid like electrical device that is governed by the physical properties of diffusion and molecular motion. The functioning of brain is related to underlying wave particle dualism. So, nature teaches the true science with physics. So, physics is an efficient tool. Science and technology should be used in a balanced manner. Science and technology should be used in a balanced manner. They should not become weapons to destroy the nation. If it becomes a weapon to destroy the nature, then only we are getting the global warming and negative impacts due to the technology. So, the science and technologies should be used in a balanced way. So, we can save our country, we can increase the technology, we will be safe. Okay. Now, let's see measurement. In each and every day of life, we are experiencing measurement in each and everything. Okay. What is measurement? If a person is asking, what is your height? Oh, you will tell that 5.4 or 5.6. I don't know, like that. If your mind is not fixed, then your knowledge is less. Then your knowledge is less. So, each and every one should be very strong in measurement. So, Lord Kelvin, a scientist, he said that if you cannot express your measurement in numbers, then your knowledge is meager, then your knowledge is less. So, measurement deals with numbers. Measurement deals with numbers. It is expressed in quantitative. So, physics is a mathematical. So, measurement is a basic part of physics. So, now let's see what is a physics? The definition for physics is comparison of any physical quantity with its standard unit. With its standard unit is known as measurement. So what is a physical quantity? Okay, you are taking a pen. Okay, what is the size of pen? If anyone is asking, you have to compare it with standard unit. What is the standard unit? You have to tell that it is a 12 centimeter. That 12 centimeter, that centimeter is the standard unit. So, comparison of any physical quantity, pen, shoes, your clothes, or the inches of the TV, okay, 24 inches, 32 inches, like that you will ask in shop now. So, like that, measuring the cloth in the shop, measuring the cot, okay, cot, each and everything around us. So, you have to tell it in a standard unit. So inches, centimeter, kilometer, length, like that. So that standard unit should be. Now, fundamental quantities and derived quantities. These are the two types of physical quantities. Okay, what is fundamental quantities? Fundamental means it is the basic one. Fundamental means it is the basic. So, these basic quantities cannot be expressed in terms of any other physical quantities. It cannot be expressed, it will be itself only. For example, length, mass, time, electric current, temperature, luminous intensity, these will never change. What is the room temperature means? It is 32 degree. It we cannot say what is the length of the room. No, it cannot be. So temperature is expressed in temperature, length is expressed in length, mass 1 kg of tomato only we will ask. We will never ask 2 hours of tomato, 3 hours of tomato. No. So, like that, this cannot be expressed in other physical quantity, cannot be expressed in any other form. It will be itself. Okay, this is the fundamental quantities. What is the derived quantities? Derived means we all know that derivations came from a equation. Okay, there should be a starting point, there should be a value, then only we can derive by one step to other step, and finally we will get an answer. Like that, derived means it will be started from a fundamental. So fundamental quantities will be converted to derived quantities. So the quantities that can be expressed in terms of fundamental quantities are called derived quantities. For example, area, volume, velocity, acceleration, these everything are derived from the fundamental by applying the division, multiplication, everything. So applying the multiplication, division in fundamental quantities, we can get the derived quantities. Okay, for example, area of the rectangle. What is the area of the rectangle? Length into breadth, length into breadth. So length, breadth, they both belongs to length only. So there comes two length. Okay, two length. So length into length. So multiplication, length into breadth. So there is a multiplication. These both are what? Length is what? It is a fundamental quantity. So the combination, the multiplication, division, addition of fundamental quantities is called derived quantities. Okay. You have understood, children? Okay. Then fundamental quantities are further classified as vector and scalar. Vector means it shows only magnitude. Scalar means it shows the direction also. So if it shows only the magnitude, then it is called vector. If it shows the direction also, it is known as scalar. Okay. Now, types of measurement systems. For measuring all kinds of these fundamental and derived quantities, we need a system of units. Okay, for measuring the fundamental quantities and derived quantities, we need a measuring system. So, in earlier days, there was a common system of units in mechanics that is known as measurement system. There are three types of measurement system in olden days. First one is FPS system. FPS. F means foot, P means pound, S means second. Foot, pound, second system. Okay. In that system, uh, the basis unit for measuring the length is foot and mass is pound, time is second. For measuring length, they will tell foot. For measuring mass, they will tell pound. For measuring the time, they will tell second. It is a British engineering system. It is a British engineering system. And next one is CGS system. CGS system. C for centimeter, gram, and second. It is a Gaussian system. It is a Gaussian system. For measuring the length, they will tell centimeter. For measuring the mass, they will tell gram. For measuring the time, they will tell second. And next one is MKS system. It is a meter, kilogram, and second. So for measuring the length, they will tell meter. For measuring the mass, they will tell kilogram. For measuring the time, they will tell second. Now, units and its types. The process of measurement is basically a process of comparison. Measurement based upon comparison. So, comparing a physical quantity with its standard one is known as measurement. To measure a quantity, we always compare it with a reference. Okay. For measuring a pen, we will take a scale or we will take a measuring tape. So, then only it is a reference. The measuring tape is a reference. By comparing the physical quantity with the reference one, we will tell the measurement. For example, when we state that a rope is 10 meter long, okay, in your mind you think that a rope, there is a rope, okay, the rope is 10 meter long, rope is 10 meter long. It is to say that 10 times the 1 meter. Will you say that 10 times the 1 meter? 1 meter into 10 is equal to 10 meter. So the 1 meter is the standard one. The 1 meter is a standard one. That 1 meter is the unit of the quantity length. The length's quantity is 1 meter. Okay. An arbitrarily chosen standard of measurement of quantity which is accepted internationally. okay, standard of measurement of quantities which is accepted internationally all over the world, then it is called unit. Okay. Okay, the types of units, what are the types of units? Fundamental units and derived units. Fundamental units are basic one which is directly, and derived units are, it will be a multiplication or powers or division of fundamental units. Okay, these are derived units. As we already saw, fundamental quantities and derived quantities, the units for fundamental units are fundamental units, and for derived units are derived units. Now, SI unit system. System International is the French abbreviation for SI unit system. Okay, the system of units used by scientists and engineers around the world nowadays, till now, they are using SI unit system. Okay, which is also called metric system. Finally, we saw three types of system, isn't it? FPS, CCS, and MKS. The MKS system is known as metric system, and finally it is accepted by all over the world, and it is the System International. The SI with a standard scheme of symbols, units and abbreviations were developed and recommended by General Conference of Weights and Measures in 1971 for the international usage in scientific, technical, industrial and commercial work in each and every field. Every field, engineering works, each and every measurements from now. At 1960, since 1960 till now, we are using SI unit systems. The systems make use of only one unit for one physical quantity. One physical quantity, one unit. If it is a length, then 1 meter only will be the unit for that. If length is a physical quantity, okay, length is a physical quantity, we should express the length only in meter. Okay. If mass is the physical quantity, then we should say kilogram is the unit. Time is the physical quantity, then you will say second is the unit. Okay. In the system, all the derived units, okay, derived units can be easily obtained from the fundamental units. Derived units obtained from fundamental units. It is a metric system, which means multiples and submultiples can be expressed in powers of 10. If, for example, meter, okay, meter should, in a question it is written as kilometer, meter it is written as kilometer, then we have to convert into meter. Okay, if the length is given, okay, the length is given in kilometer, okay, then we have to convert it into meter for solving the problems or anything. So we have to convert into meter, then we can convert the kilometer to meter in terms of power, so finally it came to a conclusion that this system of unit has only one unit. One physical quantity has one unit. Okay, in the picture you are seeing kilogram, okay, kg for mass. Okay, mass is a physical quantity, kg is its unit, and length is a physical quantity, m for meter. Okay, next s means second. Second is a unit. So what is the physical quantity for second? Yeah, you're right, time is the physical quantity. Next one, a means ampere. Symbol of ampere is a. So ampere means the basic quantity is electric current. Basic quantity is electric current. Electric current is termed in ampere only. Okay, next, temperature is denoted in Kelvin. Next, amount of substance is expressed in mole. Then luminous intensity is expressed in candela. Okay, have you understood, children? Now, measurement of length, measurement of mass, measurement of time. Let's see. Okay. The concept of length in physics is related to the concept of distance in everyday life. Okay. What is a length? Length is defined as the distance between 2 points in a space. Here is a point and here is a point. The distance between these 2 points is defined as length. Okay. The SI unit of length is what? Meter. The SI unit of length is meter. For example, large objects like galaxy, stars, sun, earth, moon, etc. and their distances constitute macrocosm. we will tell it as macrocosm. It refers to a large world. For measuring the distance of the large world, like the galaxy, stars, moons, we will tell it as macrocosm. Okay. On the contrary, for measuring very minute particles, molecules, atoms, protons, neutrons, electrons, bacteria, and their distances, okay, and their distances, we will tell it as microcosm. Microcosm, which is a small world. Okay, distance ranging from 10 power minus 5 meter to 10 power 2 meter can be measured by direct method. Can be measured by direct method. For measuring astronomical distances, we cannot use direct method, we have to use indirect method. Okay. Okay, for direct methods we can use screw gauge, vernier caliper. Okay, for small distances we can use screw gauge, vernier caliper. For measuring the large distances we are using triangulation method, parallax method, radar method. Okay, this is the measurement of length. Okay, do you understand how we can measure a length? A distance between two points is known as length. Length or the SI unit is meter. Okay. For measuring large distances, galaxy, we are using indirect method, triangulation, parallax, radar. For measuring the small, which is called as microcosm, we are using meter scale, screw gauge, vernier caliper. Okay. This is the difference between microcosm and macrocosm. Okay. What is screw gauge? You may have done in practicals. Okay. Measurement of very small distances. Okay, like accurate measurement of objects up to 50 mm. 50 mm. Okay, objects such as 50 mm, we can use screw gauge. Okay, the principle behind screw gauge is linear motion using circular motion of screw. By screwing the circular motion, this linear motion gives the magnification. Okay, in vernier caliper, it is a versatile instrument for measuring the dimension of object like diameter of a hole, depth of a hole. Okay, its least count is 0.01 centimeter. Okay, next, measurement of large distances such as height of a tree. Okay, you are standing in the sand. Now we have to measure the height of the tree. What will we do? We have to apply their triangulation method. Triangulation method means like that in what I have to say, like that cos theta, sin theta, you have already studied in your 10th maths, I think. Okay, for measuring that large distance like height of a tree, we can use triangulation method. Triangulation method, like tan theta equal to opposite side by adjacent side. By applying that formula, we are getting the triangulation method. Distance of the moon from the earth, distance of the planet from the earth. Some special methods are adapted, like parallax method, radar method. Okay, what is parallax method? Very large distances. Okay, such as to measure the distance of star from the earth. Okay, you have to measure the distance of star from the earth, we have to use parallax method. Okay, next, radar method. What is radar? Full form of radar is what? Yeah, radar stands for radio detection and ranging. Okay, radar can be used to measure accurate distance of a nearby planet by such as Mars. Mars, okay. Our nearby planet is what? Mars, okay. Radar can be used to measure the distance of the Earth from the Earth to the Mars. So the distance between Earth and Mars can be determined by radar. Okay. This can be used to measure large distances. Okay. Next, measurement of mass and time. What is mass? Mass is a property of matter. It does not depend upon temperature, pressure and location. Okay. It is a quantity of matter contained in a body. 1 kg tomato, 1 kg potato, like that. It is what is the SI unit of mass? Kg. It is expressed in kilogram. Okay, these mass may vary from tiny mass of electron to the huge mass of universe. Okay, tiny mass of electron 9.11 into 10 power minus 31 kg. It's the mass of electron. Okay, what is the mass of universe? It's equal to 10 power 55 kg. Okay, the mass of electron, not only electron, also the mass of universe can be calculated. Okay, normally in common balance, using the common balance in grocery shops, we are using the mass of an, we are determining the mass of the object. For measuring large masses like the planets, stars, Okay, how will you measure the mass of a planet, mass of a star? We can make use of gravitational method. Okay, for measuring the large masses such as planets, stars, we can use gravitational method. For a simple mass of objects like kilograms, we can use common balance. Okay, for measurement of very small atomic, subatomic particles, we can measure it by spectrograph, mass spectrograph. Okay, have you understood? Okay, next, mass of time. How do you measure time? A clock is used to determine the time interval. Okay, atomic standard of time is based on the periodic vibration produced in a cesium atom. Some of the clocks developed later, okay, are electric oscillators, electronic oscillators, solar clock, quartz clock. Okay, atomic clock, which keeps time on the basis of radiation from cesium atoms, is accurate about 3 millions of the second per year. In the previous days, atomic clocks are present in the world. Now only electric oscillators, electronic oscillators, solar clock, quartz clock, like that developed. So, for measuring the time, clocks play a major role. Okay, now theory of errors. The foundation of science and technology, okay, is measurement. The basic thing for science and technology is measurement. Without measurement, there is no science and no technology. Okay, the result obtained from each and every measurement, every experiment may be correct. No, every time it may not be correct. Sometimes there will be error. Sometimes there will be error. What is the error? Error is defined as the difference between true value minus measured value. True value minus measured value. For example, you think there is a pen. Okay, there is a pen. This length of the pen is 10 centimeter. The length of the pen is 10 centimeter. Okay, it is a true value. It is written in the packet itself. Okay, now I am taking a scale. That scale is old scale and it is bitten somewhere, scratches, and it became very old. Okay, and now I am taking the length. Okay, now I am taking the length with it. Then I am getting 9.8. I am getting 9.8. Okay, then the true value is what? 10 centimeter. Okay, there is a difference, no? 0.2. There is a difference. So that is the error. That is the error. It occurs. Error occurs frequently. Error occurs by various modes. Okay, further we can see how error occurs like that. Okay, okay, there are two different terms. Main different terms is accuracy and precision. Okay, you have to know what is accuracy and what is precision. This accuracy and precision topics comes up to your higher studies in college. If you go for engineering or further ME, there also it is a major question, what is accuracy and what is precision. Okay, okay, now itself you study what is accuracy and precision. Okay, okay, listen clearly. Okay, okay, accuracy refers to how far we are from the true value. How far we are from the true value, that is accuracy. And precision refers how well we measure. How well we measure. How we measure, that is precision. And how far we are near the result is accuracy. Okay, let me tell the example and make you understand. Okay, okay. Now let's say, okay, your height is 5.9. Okay, your height is 5.9. Now you are measuring it with a yardstick. You are measuring it with a yardstick and you are getting the value 5.1. You are getting the value 5.1. It is correct? No, it is not correct. Then it is inaccurate. It is not accurate. Okay. Now you are taking a laser yardstick. Laser. Okay. Laser will every time it will give a correct reading only. So you are taking a laser yardstick and it will give 5.9. It is giving a value 5.9. Okay, now it is correct or not? Yes, it is very accurate because your height is exactly 5.9. Your true height is 5.9 and the laser yardstick gives 5.9, but the normal yardstick gave 5.1. So now it is very accurate. Okay, the true value is also theoretical value. Okay, next, but if you are consistently measuring your height, okay, the same height you are measuring with the yardstick, normal yardstick வச்சு ஒரு 10 time நீங்க measure பண்றீங்க, you are measuring 10 times the same value, you are getting 5.1, 5.1, 5.1. Okay, 10 times you are getting 5.1. Okay, then it is called precise. It is called precise. Do we understand? By measuring a normal yardstick, you are getting 5.1. Then you are using laser yardstick, you are getting 5.9, the true value. That is the accurate value. That is accuracy. Next, further you are measuring for 10 times the same value coming by the normal yardstick, same value 5.2, 5.2 or 5.1, 5.1, the same value at the 10 times, then it is called what? Precise. Same value many times is called precise. Single value, true value is called accurate. Do you understand? Okay. In engineering projects such as road and construction, they require very precise information. Precise only, not accuracy. Okay. Precise will be maintained in engineering projects. Okay. If a measurement is precise, that does not necessarily mean that it is accurate. However, if the measurement is consistently accurate, it is precise. Okay. Consistent the time of same value it's coming, no, then it is precise. Okay, for example, if you are in a room, the temperature of the building is 40 degrees Celsius, it is measured by a weather thermometer. Okay, and again it is measured by a thermometer, it is giving 40 degrees Celsius, then it is accurate and precise. It is also accurate, it is precise, because we are measuring it for 10 times, the same time it is giving 40 degrees Celsius, and first we are measuring up to last 40 degrees Celsius, its normal true temperature is also 40 degrees Celsius, then the answer is the temperature is accurate and also precise. Okay, another example I am giving you for better understand. In a refrigerator, okay, in a refrigerator you are measuring the temperature by using a thermometer. Okay, first of all I will tell the true reading, what true temperature of the thermometer, that is 9 degrees Celsius. Okay, 9 degrees Celsius is the correct temperature of the refrigerator. Okay, now you are measuring using thermometer for 7 or 6 times. Okay, first time it is coming 10.4, next 10.2, 10.3, 10.1, 10.2, 10.1, 10.1, 10.1, like that. Okay, but true value is what? 9 degrees Celsius. Okay, yeah. Now here see, we can say that the thermometer is not accurate. Thermometer is not accurate. But what is here? It is precise. What is here? Precise. Because that 7 or 8 times same 10 related values only came. So that is precise. 10 related value came, that is precise. But 9 did not came, hence it is not accurate. So it is precise and accurate. Okay. Okay. Now see, in the picture you see, okay, here is a target shooting. Okay, here is a target shooting. In this target shooting I will explain what is accuracy and what is precision. Okay, watch clearly students. Okay, now you have to focus on the midpoint, that red bull. Okay, bullseye, reach the bullseye, that midpoint you have to shoot carefully. Okay, right. Now you are shooting, in the first picture you are shooting, and see, every bullets are around each and every place, not in a same place, other places. Okay, so it is what? Low accuracy, low precision. It is not accurate and not precision. Every one are in different places. Okay, see the next diagram. It is not in the center, but it went to a place, every bullets went to that same place. Okay, everyone are in the same place but not in the center place, so it is not accurate. Accurate போகல, பட் எங்க போயிருக்காங்க, எல்லாரும் ஒரே பிளேஸ்ல போயிருக்காங்க. அப்போ எல்லாரும் ஒரே மாதிரி வருதுன்னா என்னது? precise. Okay, it's low accuracy and high precision. See in the next picture, almost அந்த மிட்டுக்கு எல்லாரும் போயிட்டாங்க. Okay, almost in the mid every bullets went, so accuracy is high, precision is less. Finally see, at the midpoint, okay, in the bullseye, in the midpoint every bullets went, so this is what? High accuracy and high precision. High accuracy and high precision. Okay, do we understand what is accuracy and precision? Okay, now what are the errors in measurement? Okay, the uncertainty in measurement is called error. Okay, error is classified into systematic error and random errors. Also gross errors and many errors are there, but in your chapter only given random error, system error, gross error. Okay. In systematic errors, what is systematic errors? Systematic errors are reproducible inaccuracies consistently in the same direction. It is a consistent error. It persists throughout the experiment. Systematic error is a persistent error. Starting from the experiment till last one, the error will be there. Okay, that is the systematic error. It is a fault. It is a great fault, that is systematic error. What is random error? Random error may arise due to unpredictable variation. Unpredictable. Sometimes high temperature, sometimes low. It is unpredictable. எதிர்பாராத விதமாக. Okay, systematic error is it is done by our mistakes, sometimes by external causes, like that. Okay, that is systematic errors. Okay, how it causes, how it is minimized, like that. Okay, now we are going to see. Okay, what are the causes caused by systematic errors, what is caused by random errors. Okay, suppose for example in a random error, okay, you measure the mass of a ring. Okay, you measure the mass of the ring 3 times using the balance. Okay, 3 times you are measuring. In random error, you are measuring a mass of a ring 3 times, you are getting 15.6, 15.4, 15.8, like that. You are getting 15 related values 3 times but different. Okay, just in point variation only. Then you have to do what we have to do to minimize it. How we should minimize it? By averaging the 3 values, and you will get average panni 3 ஆல divide பண்ணோம்னா we will get a one value. Okay, that will be the best way to minimize the random errors. Okay, systematic error, suppose the cloth tape. Okay, you are using a cloth tape. Okay, you have seen now tailors are having the cloth tape. Okay, that cloth tape be stretched out. Okay, by using for many years it has become old and very loose and the teared, like that. Okay, you are using that one. Okay, then you are using, so we are getting the wrong measurement only. It is your fault. No, you are using the wrong that very stretched out years of used cloth tape you are measuring, then you will get the error only. So how to minimize it? Systematic errors are difficult to detect. Okay, cannot be analyzed. It is very tough. Okay, you have to change the measuring tap only, then only you will get the either. Okay, you have to change the tap or you have to improve the tap, like that. Okay, this is the difference between systematic error and random error. You have understand? Okay, next we will see deeply. Okay, what are the types of systematic errors? What are the types of systematic errors? Now, what are the types of systematic errors? Instrumental error, imperfections in experiment and procedure, personal error, error due to external cause, least count error. Okay, then what is instrumental error? Okay, when you are using an instrument which is not calibrated properly. What is calibrated? It is maintained. Okay, calibrated properly at the time of manufacture, production time, during the manufacture itself, it had a problem. During the manufacture time itself, the problem arises. Okay, if the measurement is made with a meter scale. Okay, now you are measuring a measurement using a meter scale whose ends are worn out. Some children are having the scales, no, the ends are worn out, torn out. Okay, like that. Okay, some ends are worn out, the result obtained will have some error. Kandipa, there will be error. These errors can be corrected by choosing the instrument carefully. So instrumental error depends upon you or the manufacturers. They have to design the perfect one. Okay, otherwise you have to select the best one, which one is perfect, which is correct. So the instrumental error arises during manufacture itself, so the choosing of instrument is the best one. Okay, next one, imperfection in experimental procedure. Okay, for example, if you are using a calorimeter. Okay, you are using a calorimeter, it is not properly insulated. Calorimeter is what it contains, a atomic bomb, like that. Okay, that fluid also it contains, so it emits radiations, heats, like that. If it is emitted more radiations and heat, then we will get wrong readings. So if in the calorimeter, if there is not a proper insulation, there will be radiation losses. So the results will be error. Results will be error. So imperfection in the insulation, okay, in insulations or some it done by us, okay, done by us. So while during the experiments we have to be very careful if the instrument is very correct or properly insulated or not, like that. Okay, next, personal error. What is a personal error? These error arise due to individuals. Okay, you may be doing your experiments in laboratories. Sometimes the experiment may get damaged by you only, okay, due to incorrect initial setting up, incorrect setting, sometimes carelessness, okay, sometimes carelessness, okay, of the individual. You are not calculating properly, okay, 10.1 will be came, then you will put 10.5 or something. It's your carelessness, like that occurs personal errors. Okay, next, error due to external causes. Error due to external causes, okay, by external conditions, by the climatic changes, humidity, pressure, like that. So high pressure or instrument la kudukumbodhu it creates error, it creates error. So errors due to external causes will be reduced by carelessness or climatic changes. Okay, next, least count error. What is least count? This word is heard in screw gauge and vernier caliper now. Yeah, it is the smallest value that can be measured by the instrument. Okay, while using the screw gauge and vernier caliper, we have to add the least count. Okay, then only it will give a correct. Otherwise, we have to use high precision instrument. For minimizing these errors, we can use high precision instruments. Okay, next, random errors. Okay, random errors. What is random error? It arises due to unpredictable variation like pressure, temperature, voltage, supply. Errors may be due to personal errors. Okay, it is a chance error, by chance. Every time it doesn't occur. It is a by chance. The instruments are very correct. You are also very correct. It is unpredictable. Okay, that is random error. It's a chance error. When different readings are obtained by a person every time he repeats the experiment, different readings, okay, you are getting a different readings, 10.1, 10.1, 10.5, 10.6. The same experiment you have to get same reading over the 6 times also, but he is getting different reading. Then what you have to do? You have to take the average mean value. The 6 values will be divided by the added and divided by 6, then you will get a single value. So for minimizing random error, we can do average mean value. Next, what is gross error? Gross error is caused due to sheer carelessness of observer. Carelessness of an observer. Who is observer? I am or you are. Okay, while doing the experiment, we are the observer. We make the mistakes, that is gross errors. How we are making the mistakes? Reading the instrument without setting properly. First of all, while doing the experiment, we have to check now it is correct or it is placed correct place. Without checking, without reading anything, we are setting the works and making the errors. Next, taking observation in a wrong manner without bothering the sources of error. Okay, sometimes you are taking the readings in a wrong way. Ma'am told to take like this way, but you are doing in another way. It will also create errors. Okay, recording wrong observations, recording wrong and using the wrong values in calculations, using your thinking will be in other place and your mind will be in other body only in the laboratory, then you can also make errors. Okay, these are gross errors. Have you understand, children, what are errors or the types of errors? Okay, have you understand? Okay, now error analysis. Okay, what is error analysis? How we can analyze the errors. There are a lot of errors. How we can analyze it? There are a lot of formulas in this and problems we can see in further classes. Now I will give a brief definition about this error analysis. First of all, absolute error. What is absolute error? The magnitude of difference between true value and measured value of a quantity is called absolute error. The difference between true value and measured value is called absolute error. Next, what is mean absolute error? Arithmetic mean of absolute error is called absolute error. Absolute, what is absolute error? Difference between measured value and true value. Okay, that is absolute error. What is mean absolute error? The arithmetic mean of absolute error is mean absolute error. Arithmetic mean of absolute error is arithmetic error. What is relative error? Relative abdinale what? Relative means what? It is a combination. It is a combination. Okay, then there will be two things. Okay, we are combining with two, relating. Okay, the ratio, there will be a ratio between mean absolute error and the mean value. Okay, mean absolute error divided by mean value is called relative error. It is a fractional. Okay, when we are doing as a ratio, then it will become a fraction, no? Then it's a fractional error. Okay, okay. Next, what is a percentage error? What is a percentage error? It will be in percentage. Okay, the relative error is expressed as percentage error. Okay, the relative error which are finding by a fractional method, then we have to multiply into 100, then it will give a percentage error. Okay, that's all. Now it's time for you. I'm giving the homework and also assignment. Okay, first of all, you have to write 15 one words from the topics which I have taken. Okay, refer your book, prepare well, and write 15 one words from the topics. Next of all, you have to write in your classwork table number 1.1 to 1.11. Okay, 11 tables in the book. You refer and learn and write in your classwork. Third one, what is radian, what is steradian? It is in page number 11. You study thoroughly and write it. Next, what is the process while heating the metallic rod? Explain it. Next, what is the language of physics? Next, differentiate between reductionism and unification. Next, branches of physics. Next, differentiate between accuracy and precision. Okay, these are the questions for your assignment and classwork. You have to come to the school with your parents and submit it. Okay.